about the devices that many of you are using right now as I speak, the phone in your pocket. So what we're going to focus on today is the same types of issues that I've seen as I've gotten into this industry in mobile security back in 2013, 2014, when I graduated with a cybersecurity degree. Unfortunately, due to the lack of attention on mobile versus your traditional enterprise network, your cloud, other things that you have budgeted for, these threats, have continued to evolve without even being addressed in the basic form. So we'll focus today on some of those threats. I'll show you some real examples, some apps you may have installed on your phone today, and hopefully get you to pay more attention and help spread the awareness when you're downloading, looking at the App Store, choosing what's installed on your phone in personal and work life, and prioritizing security. So if we can get the slide deck going. Thank you. So if we skip ahead to a few slides, we have our first type of threat. So this is, the very basic thing that came out as soon as, the iPhone released, as soon as your Android phone released back in 2011, 2012, just simply harvest your data. So what's a lot easier than trying to break into an enterprise network, find an exploit 0-day, get onto the router, pivot to the server, have persistence, get access to the data, and then export it? Well, just ask the user if you can have it. And most of the time, they'll give it to you. So we'll take a look at some examples of, in the App Store today that are still doing this. But, what's the benefit here? It's legal. You're not breaking any rules. It's easy. There's not very complex, attacks, hacks you have to do. You just have to make something useful. And potential for mass data collection. So we're not talking about, the 10,000 people at your agency, 100,000 people at your agency, the million people that work for the government. We're talking about billions of people that you're able to collect data from through this methodology. And then, of course, what makes those advanced attacks easier? When those people in that agency, those people, what they're doing, who they talk to, what they like, you have all that information about them, becomes a lot easier to then spearfish and get inside that agency through some human, networking there. So how do we detect these? The next slide, please, is we simply have to watch them. So you see that high-powered NFL camera on the left-hand side. When these applications are actually running on your phone, after you download it, you hit yes, accept, you can have my contact data, you can have my text message data, whatever it is. What do they actually do with that data? You would think, the App Store providers are focusing on this, but simply they're trying to get more apps in the store because they make billions of dollars every time you download, get served an ad, pay for an upsell in the application. So what you need to do is automate the discovery of what these applications are doing on your phone. So we'll skip ahead to the next slide, please, for the next type of threat. So privileged and backdoor applications and SDKs. When we're looking at a more advanced attack method, what's another approach you can take? Well, you can get inserted at the supply chain. So my device, your device, most of the devices in our household are all manufactured in the same place. We all know where that is. And we've seen over time, things are snuck in either accidentally or purposefully, don't know, but they are able to then collect at a lower level on your devices the data that you use and handle on your phone. So some advantages here, you can get complete compromise. You're not talking about getting data from one app. You're talking about getting all the data on your phone because you're at a lower level on the device. You have persistence there. You're not getting replaced with updates or anything like that. You're already in the base hardware. And of course, you're hard to detect because you're operating at a lower level than what the operating system providers can protect. So when you download an app from the store, it can ask you for that permission. You have to hit yes or no. If I'm installed at the base level on the phone, when you get it out of the box, Google's software on top of that has no control over me. I can subvert that and get access to your information at a lower level. So on the next slide, we'll show you an example of that on the right-hand side. Back in 2016, we found the #1 phone on Amazon at the time, $50 phone manufactured by a company based in Florida in the US. And every 72 hours, it would extract your text messages, your GPS coordinates for those last 4 days, and extract that information back to China. And so what this was doing, it was collecting this information, but also having a remote command and control capability. So they could perform searches for specific names, addresses, whatever it might be on your device. If they found it interesting, they could add more capabilities to it. So expand that footprint, expand that collection capabilities on the device. And this wasn't hiding out there. This is millions of people using a phone branded with Amazon's own brand, sold in the US by a US manufacturer, US distribution network. But the critical piece was the supply chain. The device was manufactured in a place where untrusted things can happen. So how do we find more of these things? Well, we have a capability here to do flow-based vulnerability scanning. And this is a technical thing. We can dive into more detail later if you want. But essentially what it does is it looks at the giant code graph, everything that can happen on that device, and identifies interesting things. It collects your SMS data, and then it reaches the network here. And that can raise a flag to then inspect it and find things like this. And to this day, we've got about 275 different CVEs discovered and produced with this. So this is not something that's just on paper, that you can leverage, but it's something that's out there being used to find things like this to this day. So we'll dive into some specific examples here, and I want to see some hand raises on the next slide if you've got this application on your device today. So this is something that you may use at a conference like this when you get a business card to digitize it. And you might download it, install it, because below the paid ad, it's the #1 recommended app for this purpose on the App Store. Cam Scanner, it's got 1.3 million ratings, 5 stars. As an average end user, you don't even have to look. This is the recommended app. It's got 1 million users, however many people have used it. It's got a 5-star rating. I'm going to install it and use it right now. Well, if we skip over to the next slide, we'll take another look at this app, but from a tooling perspective. Oh, shoot. 100 threat score, hard-coded key, communicates with high-risk location. Maybe I should take a deeper look. Next slide, please. So when we're looking at what actually happens when this app is running on your phone, we get that flag at the top, communicates with high-risk locations. And we can see on the map, 383 connections in China, 18 in Hong Kong. And we can see on the right-hand side there, some of the redacted list of connections that it's making. So as you're installing and using this application, and you hit yes, access my camera, well, where's your data going? Right here. Next slide, please. And you might be comforted because it's on the App Store. They have rules about what they can do with your data. So you go check the privacy policy. Maybe it doesn't actually collect my data. Well, what data do we collect? User-generated content. When you use our services to scan documents or images, we will collect the documents or images which you choose to take or upload. So it's out there, open, sitting on the App Store, #1 recommended app, and it's telling you it's doing all this, but people don't look. You have to actually take a deeper look and find what these applications are doing. So on the next slide, if you just simply even Google the company, well, it's pretty clear where they're located. So, these types of things, these harvesting applications that are out there, they don't have to hide from you because it's just, kind of default. You trust what's in the store. You trust it's got good ratings. You trust Apple or Google that they've done their job to protect you. But as a government user, government agency, you especially have to pay attention to where your data is going and what's happening to it when you use those applications. So, by the way, the 2 other apps they offer on the store, Cam Scanner for business cards, Cam Scanner for Salesforce. So can you imagine a better way to collect data about a social network of people who are talking to each other, who know each other, what their contact information is, than just to ask them for that data yourself? Hopefully take a second look at whatever you're downloading on your store. So this is an example of potentially a bad app behaving badly. We'll quickly cover another example of a good app behaving badly on the next slide. So I've been talking to a few people yesterday at the reception around the event, and a lot of people have similar stories of a coworker, a family member, someone that gets phishing attack to get their bank account drained. So they'll get a text message, email, phone call, whatever it might be. So you may want to install an app to help protect you from that. We have an example here: caller ID, phone block, 10 million downloads, 4.3 rating. So this might help me actually protect myself from those phishing attacks. Next slide, please. Oh crap, another 100 rating. What happened here? If we look at the next slide, we'll see not only does it access that sensitive data, the SMS messages, the phone calls. Well, of course it does, because it needs that data to protect me. But we also see application programmatically leaks data. So we should take a deeper look at that. Next slide, please. So we see on the left-hand side some of the technical output showing that when the SMS is received by the code, it programmatically logs that SMS, meaning it's taking data from a safe, secure place on the phone, putting it to an insecure place. So this is not, something that was likely intentional. It might be just a flaw left in from development, whatever it might be. But it's a good app trying to do good things, but actually making you more insecure in the process. So we can see on the bottom even an example from our black box test where a message that we sent to the device is logged in that file. So you can not only see it in the code, but you can see it at runtime actively happening on the phone. So next slide, we can take a quick look at some of the things that we can do to help address this problem. So as an agency, you likely have an MDM, Intune, Ivanti Mobile Iron, Workspace ONE, whatever it might be. If you find one of these applications, you can ban it. Don't let your users install it. So your cam scanner app, that might be a first one to get added to that ban list. You can update your network defense. You likely already have a VPN firewall in place. Take those IP addresses, take those domain names, add them to that list to make sure they don't get hit from the device. And, my primary recommendation here, and hopefully you can take this on, is to warn the users. If people aren't aware of these types of risks, they're not going to look for them, and they're not going to, be aware that they have, application on their device, potentially they're looking to install, that's simply just stealing their data from them out in the world, blatantly. And of course, you can always report to the vendor. If they're a US-based manufacturer, US-based company, they'll likely address the problem. But the key for the government is there has to be some dedicated attention and budget toward this issue, because in our work with the US government this year, we found even in US government developed applications, 3 different instances of Russian or Chinese connections inside the government's own apps that they're pushing out. And that's because the supply chain, not only for the devices, but for the application code base, where developers are pulling things from the online stores, pulling things from the Maven repositories, other places to build their application. Well, guess what? Those attackers can insert themselves in that process too. So thanks for your time today, and happy to answer any questions.